And tell me about ASSR. How would you use that with regards to things like auditory neuropathy spectrum disorder? How would you apply ASSR technologies to help you with a diagnosis of ANSD?
Well, neither ABR nor ASSR will be useful in terms of detecting the threshold of hearing for a child with auditory neuropathy.
And I'm glad you mentioned that, because I've been in discussions where people have said that if you have only a mild sensory neural loss, ASSR might be a little better tool than ABR with regard to the diagnosis of ANSD. So that's not correct.
It's not correct. And when you have a mild hearing loss, clearly there's activity in the brainstem, and that activity is getting up to the brain, and somehow the information is getting through. But it's the timing of the information
Sure.
that is off, and all of these detection techniques require that the timing be more accurate. So you may see a response. You can't predict hearing threshold with either ABR or ASSR.
Yvonne, thanks so much. That was great. I'd like to know a little bit more about the advantages of ASSR as compared to ABR, particularly with regard to speed and accuracy of hearing estimation, hearing threshold estimation.
Okay. Well, I've got a lot to say about that, Doug, but I'll try to keep it brief. I think ASSR has gotten a really bad name in audiology. And the reason I believe that that's happened is that early machines just didn't take advantage of all the processes they could use to detect a response accurately. And the thresholds that were being produced by some of the early machines were too high. And they didn't meet the standard of audiologists, and they certainly didn't meet the standard of tone burst ABR in terms of predicting threshold. And let me just say a little bit about how it works. I think there's also some misconceptions about ASSR. The activity in the brainstem neurons that produces an ABR is the same activity that produces an ASSR. ASSR is simply, I think, a rather clever technique in that it takes a stimulus and presents it at a certain rate. And then, by going into the EEG and doing a frequency analysis of the EEG, you can look for that particular rate to stand out from the others. It's very much like what we do with otoacoustic emissions when we do a spectral analysis and look for that spike. So you can take a 1,000 hertz tone, or a tone burst, or a chirp, and you can present it at a rate of, say, 90 per second. And then you go into the EEG and do a spectral analysis, simple to do with today's technology, and look for a spike in the EEG at 90 hertz. Is the activity at 90 hertz bigger than the surrounding frequencies? And that's all it is. It's a clever way of detecting the response. And I always like to think of it's as if you had a flashlight, a dim flashlight way in the distance, and you had to detect whether it was on or not. Well, if you flash it on and off, it's much easier to detect that it's there than if it's simply in a steady state.
Oh, that's a great analogy.
So ASSR in and of itself has really no flaws. It's simply, as it was initially implemented, was not really taking advantage of everything. The way that the detection happens in ASSR is either by looking at that amplitude, as I was measuring from the spectral analysis, or looking at the phase of the response and seeing if it's correlated to the phase of the stimulus. Okay? So you should have a certain phase of the response if it's truly responding to the stimulus. The machine that I am very impressed with is the Interacoustics Eclipse, because it not only looks at phase, it also looks at amplitude, which the other machines would use one or the other. On top of that, it looks at the phase and the amplitude for the modulation frequency of the tone, as well as many harmonics of that modulation frequency. So there's much more information going into detecting this response, and consequently you can see the response at much lower levels. The biggest advantage of ASSR is that you can present multiple stimuli simultaneously. You can use, by using different modulation frequencies for each frequency that you want to test, you can do 4 frequencies in each ear at the same time. And the time savings is enormous. And as long as we're getting the same kinds of thresholds, and if we can do it that much quicker, it's going to speed up the whole process of newborn hearing screening and follow-ups, and the advantages can be huge.
And what are the most common 4 frequencies that are tested simultaneously through ASSR?
Well, you can choose those frequencies, but standardly it would be 5, 1, 2, and 4.
Okay. And am I right that with ASSR you can go to a louder presentation level than you could with an ABR?
You know, that's more of a situation related to the type of stimulus. With a tone burst, it's not as big an issue with ABR, but I think that's more related to the earphone and the stimulus than it is the technique, not related to the technique.
All right, now one thing that's come up quite a bit in the literature and some panel discussions I've been on is this issue of using ASSR on a child with auditory neuropathy spectrum disorder. So the thought is that you can't get an ABR by definition because the child has ANSD. However, some people have said that on that same child you might be able to get an ASSR response if the hearing loss is only a mild, perhaps 40, 45 dB pure tone average. Is that correct, or what are your thoughts on that?
Well, it is correct that you may be able to see a response. You may also be able to see an ABR. The problem is that neither of those can be used to measure the threshold of response, to predict the hearing levels of those children, because there's just not enough synchrony in the response. And all these detection methods expect some synchrony, expect some phase cohesion and that sort of thing. So there's no easy way to get a threshold measurement electrophysiologically right now using any of the brainstem techniques.
Okay, thanks. So if you were going to set up a clinic today and you were going to be working primarily with babies referred in because they hadn't done well on their screenings, and you were going to look at quantity, you were going to look at quality, you had all these tools available, what type of system, what preferred system would you have and why? What would be the rationale for supporting that particular system?
Well, as I said, I'm very impressed with the Interacoustics Eclipse, which will allow the user to do either chirp, narrowband chirp ABR, get a bigger response, or use the narrowband chirps in simultaneous recordings for ASSR. Personally, I would go right to the ASSR because of the time advantage.
I see.
Rather than doing 4 frequencies in each ear individually, you do them simultaneously, and I think that time advantage may be enormous. Now, I've seen data from an excellent study in Brazil on infants and toddlers with hearing loss, all degrees of hearing loss, where they did a side-by-side comparison of tone burst ABR, chirp ABR, and chirp ASSR using the 4 frequencies in the 2 ears simultaneously. The thresholds are indistinguishable.
Oh my goodness.
So there's good proof that the data, or there's good data that shows that you can get the same thresholds using ASSR. The advantages of the interacoustics machine are the stimulus, that narrowband chirp. Again, it's completely invisible to the user. You simply select that stimulus. And I like to call it the free lunch. You select chirp stimulus and you get twice the amplitude without doing anything else.
That's fantastic.
The stimuli are all calibrated for frequency region and for level. And so from an audiologist standpoint, there's ease in the recording and bigger responses, quicker responses, and all of the features that help you determine that you have an accurate response.
Fantastic. Well, thank you very much for your time, Dr. Sininger. It's always a pleasure to work with you.
Thank you, Doug.